in case you don't know what a node is just a part of the circuit or a junction on the circuit where multiple circuit elements are connected to one another. So here we have a node because the voltage source is connected to the resistor, so that's node 1. Here's the next node because these 3 resistors are connected to each other. We'll call that node 2. And then finally a third node here where these 3 resistors are connected. And then this is node 3. So node 1 is easy, where there's 100 volts voltage source connected to it. The voltage just equals 100 volts. And then for node 2 and node 3, it's a little bit more complicated. We'll have to apply KCL. So what you're going to do is you're going to define a direction for the current in each branch. So just draw some arrows. It doesn't matter, for these problems, it doesn't matter what direction you define the current, as long as you keep it consistent for all of your KCL equations, you'll still get the same answer. So our KCL equation at node 2. So don't let the summation notation of like Kirchhoff's laws confuse you. It's very simple. So for current, it's just that current entering equals current leaving a node. So for node 2, that means that the current through this 5 ohm resistor is equal to the current going through the 30 ohm resistor and the current going through the 10 ohm resistor. Because the current through the 5 ohm resistor is entering the node, and then these other 2 currents are leaving. And then we just use Ohm's law to get the to get an expression for the current through the 5 ohm resistor, which is just voltage of node 1 minus the voltage of node 2 divided by the resistance. And the voltage of node 1 is just 100. So that's 100 minus V2 divided by 5 equals the current leaving the node, which is the current through the 30 ohm resistor, which is V2 minus 0 over 30, right? Because the voltage on this side of the resistor is 0 because it's the reference node, plus the current through the 10 ohm resistor, which is V2 minus V3 divided by 10. And that's it for, that's how you set up the KCL at node 2. Next we'll do node 3. And then the current entering is just the current through this 10 ohm resistor, which is V2 minus V3 divided by 10, equals the current leaving, which is the